So chapter 6 is just kind of an overview of the formation of our solar system, and we're going to be talking more about the sun and each of the planets later. But to just kind of look at our solar system, actually on your Unit 2 exam, believe it or not, one of the simpler questions, and remember some questions are simple and some questions are hard, one of the simpler questions is going to ask you if you know the order of the planets from the closest planet outward. So here they are. We have Mercury, Venus, Earth, Mars, and those are rocky planets. And we believe that the rocky planets, and I don't know if this is kind of a recent belief, but we think that these rocky planets are younger, than the gaseous or Jovian planets. Then we have Jupiter, Saturn, Uranus, Neptune. Those are all 4 gaseous planets. And then we have what used to be called a planet, and now is called a dwarf planet, Pluto, and its fellow dwarf planet, Eris. So, and just to kind of mention, we'll talk more about this, but between the last terrestrial planet, Mars, and the first Jovian planet, Jupiter, we have what we call the asteroid belt. So the distance between the first 4 inner planets is pretty close compared to the distance between the outer planets. Okay, so kind of drawn to scale here. If you visited Washington, D.C., you might recognize kind of the landmarks down there. So beyond Neptune, then we have the dwarf planets, Pluto and Eris. So just a little bit about the sun. The sun goes through cycles when it is rambunctious and energetic, and when it's rambunctious and energetic, it can send out a lot of charged particles and a lot of solar events that get us all excited, and then it goes through quiet times. Right now it's kind of ramping up for a solar maximum, and this right here is kind of showing you one of the things that the sun does. I believe this is probably a coronal mass ejection, where the sun is literally, material from plasma from the sun is going to have so much upward velocity that it's going to escape the gravity of the sun, and you're going to have a chunk of charged particles spread in one direction. Hopefully it's not in the direction of Earth, eh? So it's looking kind of active there. It's not always active. Another sign of an active sun actually is something that Galileo saw through his telescope. Isn't that cool? Galileo saw these sunspots, and sunspots are an indication that the sun is in its active state. So when our solar system was being formed, it was kind of formed out of the common, one big, what we call solar nebula. You know, we've talked about nebula in this class. And of that solar nebula, 99.8% of that mass ended up as part of the sun. Okay, so the remaining 0.2% is part of the planets. Now, the sun is, like any other star, actually has fusion, nuclear fusion going on in its core. And it is converting a very small amount of a very small mass of matter into a lot of energy. According to Einstein's, energy is equal to mass times the speed of light squared. So our sun is creating energy. None of the planets are creating energy. Then on to Mercury. Doesn't it, the grayish kind of cratered kind of looks like Mercury really looks like our moon. And when we talk about, I have photos side by side of Mercury and the moon. Mercury is, for all intents and purposes, we think geologically dead, which means it's not ooey gooey in the center, which means it won't have like plate tectonics, it won't have earthquakes and volcanoes and that sort of thing. So another thing about Mercury, and actually this kind of goes along with it being geologically dead, is its crust has these kind of jags in them, kind of steep cliffs. We call scarps sometimes, C-A-R-P-S. And those scarps, those kind of breaks, most likely were created as Mercury cooled. Okay. Now, another thing about Mercury is that the side of Mercury that's facing the sun is very hot, and the side of Mercury away from the sun is very cold. And the reason for this, I kind of liken it to, if you're familiar with kind of a rotisserie, you put a chicken on a spigot, and that spigot kind of turns in front of a single heating element. Well, I kind of think of Mercury as it spins on an axis also, like that chicken spins on its little spigot, but Mercury spins so slowly that basically the side next to the heating element, the sun, gets really, really hot, and the backside gets really cold. And it has to do with Mercury's very slow rate of rotation. Then we go on to Venus. And I would imagine, I'd have to double check, but these are not photographs of the surface of Venus. Remember, all 4 of these inner planets or terrestrial planets are rocky. You could stand on them, okay? And so we understand what the features of Mercury are like because we've actually mapped them by putting a spacecraft in orbit and using, I think it was radio waves, sending down radio waves and looking for the reflectivity and then mapping. The reason we have a hard time seeing the surface of Venus is because it is shrouded in clouds. And Venus's atmosphere is thick and has a high concentration of carbon dioxide. And actually, its clouds aren't water clouds, aren't made up of liquid water droplets. Its clouds are made up of liquid sulfuric acid droplets. So there you go. So sometimes Venus, when we are concerned about the Earth warming up because of global warming, we're concerned that the Earth is going to get warmer because we are increasing the amount of carbon dioxide in our atmosphere. We kind of point to Venus sometimes because the amount of carbon dioxide in Venus's atmosphere is why it's so darn hot. It has what we call a runaway greenhouse effect. I don't know, runaway, but it has an extreme greenhouse effect. And so basically the daytime side of Venus and the nighttime side of Venus is about the same temperature, very hot. And then we go to Earth. Isn't Earth beautiful? Oh my goodness. Earth is just gorgeous. Now, one of the anomalies with our solar system actually has to do with the Earth and its moon, this Earth-Moon system. Specifically, the size of Earth's moon is just crazy big compared to any other terrestrial planet. The 2 other planets we talked about, Mercury and Venus, they have no moons. Mars has 2 ugly-looking moons. They're small and they look like potatoes. Okay, so when we talk about the formation of our solar system, we have to kind of explain this moon. One of the things about the moon is, you probably have read this too, that there's strong evidence that as life evolved or came to be on the Earth, it couldn't have happened without our moon. The Earth is the only planet that has liquid water on its surface. And it has a surprisingly large moon. Mars. Oh my goodness, where to begin with Mars? If you're like me, you're just so excited about the recent rover, the successful landing of Curiosity on this planet. Oh my goodness. And speaking of liquid water on the Earth, what is this? The end of September 2012, Curiosity just recently sent back photographs. It's a new rover on Mars, NASA's rover. Curiosity sent back photographs of Mars, and we can see like little pebbles, like stream bed pebbles. And so, I mean, those little rocks on Mars could only be as they are if there was running water at some time on the surface of Mars. It's just crazy exciting times that we're living in right now. So Mars looks like Earth. If you've seen, I mentioned Curiosity is the new rover, but before Curiosity there was Opportunity and Spirit, and Opportunity is still roving around. Spirit has got stuck, and I think it's kind of out of commission right now. There are even other missions before these rovers, but we've always been curious about Mars. So Mars kind of looks like Earth. It has definitely indications that it was geologically active at one time. It has a dormant volcano, a humongous volcano, and it has these big canyons, and as this was written, I can't remember, your textbook might be 2011 maybe, but they really didn't have for sure as much evidence as we have now that water flowed on the surface of Mars. So then, of course, if you have liquid water, you're like, oh, well, maybe we have life. So that's kind of, the jury's still out on that one. Well, then we go on to the, actually there would be the asteroid belt between Mars and Jupiter. And then we move on to Jupiter. Okay, so Jupiter is our first of the gaseous planets. And isn't this just a beautiful image of Jupiter? One of the things about Jupiter, and we'll talk more in a couple of chapters, chapter 8, about an ongoing storm, kind of like a cyclone in the clouds of Jupiter, known as the Great Red Spot. But can you also see the clouds of Jupiter also kind of have these swirls, and there's other clouds and kind of these white spots down here, white storms. Just amazing. Of the planets, Jupiter is the largest. This slide says Jupiter is 300 times more massive than the Earth. So actually it's the largest of the gaseous planets. Jupiter is made up mostly of hydrogen and helium, and if you were to go stand on the surface of Jupiter, you would sink into you would sink. We'll talk more about Jupiter. Jupiter has, now that we get to the gaseous planets, all of the gaseous planets have awesome moons, and all of the gaseous planets have rings. Although if I were to ask you which planet do you think of when you think of rings, you'd probably tell me Saturn. But all the gaseous planets have rings. So this is, I want to say, an artist's rendition. I'm not sure. But Jupiter, you've probably recognized the planet Jupiter here. And this would be Io, the innermost Galilean moon. Remember, Galileo saw 4 moons orbiting Jupiter, and Io is the innermost. And the cool thing about Io is it is geologically active, but doesn't necessarily have the typical plate tectonics. It has these, it spews out kind of these sulfur-containing gases. It's kind of a strange little moon. And the other 3 moons that Galileo saw were Europa, Ganymede, and Callisto. And these moons, honestly, if we're going to kind of investigate an object beyond Mars, these moons would be great places to visit. And I'll kind of fill you in about those moons in chapter 8. Then we get to Saturn. So Saturn kind of has that kind of orangey sort of hue like Jupiter. And of course Saturn has its its awesome characteristic rings. I like this image because this is not an artist's rendition. This is, you can see like the sun must be over here, and the rings the planet casts a shadow on the rings right like that. Can you see that? It's beautiful. One of Saturn's famous moons is a moon called Titan, and we have actually visited Titan with a spacecraft. Let me come back up here. So here's Titan, and Titan has a liquid cycle, but it's not like a water liquid cycle. It has a methane cycle where it rains methane, I want to say. It's amazing. So this is kind of this is an artist's view of perhaps if you were in the midst of Saturn's rings, this is kind of what you would see floating around. So Saturn's rings are not like a solid thing. They're made up of little tiny particles. So Saturn's rings actually are kind of things like a comet, and we'll talk more about comets later, but comets have kind of a rocky component and an icy component, and that's kind of the crumblies that make up Saturn's rings. And then we go on to Uranus, and don't know if you can kind of see, but even in this picture, Uranus is depicted, can you see kind of the wispy rings there? Uranus is depicted as having just a crazy tilt. So here's its axis of rotation, kind of laying, laying on the side here, if we kind of picture it orbiting the sun. So Uranus and Neptune kind of have a blue color. So Uranus and Neptune are blue actually because of the presence of methane, or excuse me, ammonia, NH3. All right. So Uranus has moons and rings also. Then we go into Neptune, see how it kind of looks like Uranus. Now, a famous moon around Neptune is Triton. So don't get Triton mixed up with Titan. So Titan is in orbit about Saturn, and Triton is in orbit about Neptune. And then we get to Pluto, and then we get to actually kind of what we call the Kuiper belt. And we'll be talking more about that. But Pluto and stuff kind of crumblies, or small objects, relatively small objects, beyond Neptune's orbit, lying in the plane of the ecliptic, kind of make up what we call the Kuiper belt. And they're just what we think leftovers kind of the formation of the solar system. So Pluto was in the news this summer. Pluto has a large moon called Charon, and the thing about Charon is that it is similar in size to Pluto, so that actually Charon doesn't per se orbit Pluto, but both Charon and Pluto orbit a common, what we call a common center of mass. And then your textbook talks about two other moons, Nix and Hydra, or I think so, yeah, Nix and Hydra. And then actually there was a fourth moon in orbit about Pluto that was found just this summer, 2012. Well, that's when I heard about it anyway.